Welcome to all. I'm the course coordinator of Digital System Design. Today's topic, Multiplexer. At the end of the session, you'll be able to understand what is in a multiplexer, how we use in a multiplexer to reconstruct any logic functions and logic diagrams. So what is in a multiplexer? Multiplexers is a device that allows a digital information from the several sources to be routed to a single line for a transmission over that line to a common destination. So the multiplexer is nothing but a data selector, which selects a data from a multiple lines. It gives the transmits the data to a destination. The basic multiplexers has a several data input lines and a single output line. It also has a data select inputs which permit digital data on any one of the inputs to be switched to the output line. Let These are the applications of a multiplexer. Let us consider a modern stereo system, which may have a switch that selects a music from one of the four sources: a cassette tape, CD, a radio tuner, or an auxiliary input such as the audio from a VCR or a DVD. So the switch selects one of the electronic signals from one of these four sources. So if it selects a CD, then the CD is routed to a speaker. If it selects a radio tuner, that radio tuner will be routed to a speaker. So like this, it selects the data, multiple data which are available at the input side that should be routed to a output. In a simple terms, this is a multiplexer. It selects one of the several input signal and passes to an output line. So let us see an block diagram of a mux. The mux is having an n inputs, one output. It is also having a selected input. The select inputs is the count of the select inputs determined from the count of the outputs. The select inputs, the count of the select inputs, the number of select inputs will be equal to the log of number of inputs. So if we are having 8 inputs, the selection lines is equal to log of 8, log of 2 per 3. So 3 select inputs we require to operate this mux. So like this, we'll operate the mux by using the select lines. This select lines is used to select the data and it routed to a output. So here we are having a one switch. If the selection line selects an I naught, the switch is connected to the I naught, then this I naught will be routed to the output. If the selected line selects an IN minus 1, the switch connects to the IN minus 1. It is routed to the output. In this way, the multiplexer will work. So this is a logic diagram for a multiplexer. That too 2 to 1 mux, 2 cross 1 mux. Multiplexer can also be called as a mux in a short term. So here the data inputs are I1, I0. Data inputs are I1, I0, two data inputs. The output equal to 1, the selection lines also 1. So if the selection line equal to 1, then it selects the I1. If the selection input equal to 0, it selects the I0. So if the selection input equal to 0 means it selects the I0 and it is routed to the output. So if I want I0 information at the output, means that my selection line must be 0. So that the output I0 multiplied with S0. So S0 or S bar. S bar. So it is multiplied with S bar. If I want I1, I have to apply an S in the form of 1. So I1 is multiplied with S. So S equal to 0, the output equal to I0, S equal to 1, the output equal to I1. This is a 2 cross 1 mux. So let us consider a 4 cross 1 mux. So 4 cross 1 mux is having a selection lines. These are the 4 lines. 2 per 2 is a 4. So the selection lines is 2. So S0, S1. So S0, S1. If S0, S1 not S1 equal to 0, then output is routed. I0 is a output. I naught is routed to Z. So whatever the information is having present at the I naught, that will be routed to Z. If it is a 0, 1, we'll get an output as a I1 information at output. If it is a 1, 0, we'll get an I2 information at output Z. If it is a 1, 1 output, we'll get an information at I3 at Z. So this is a logic diagram for a mux. So this is a block diagram of a mux. These are the selection lines. These are the data inputs. This is a Y output. This is a 4 cross 1 mux. 4 inputs, 2 selection lines, 1 is the output. So this is a functional table for a multiplexer. AB is a selection lines. These are the input lines. This is the output. If 2 are 0, 0, it will select the C naught. So the output is low. If here the C naught is low, then only the output is L. Both inputs are low. If the C naught is high, then output is high. If the two inputs are low, high, so it will select the C1. So here the C1 is low condition, low level, so that output is low. Here the C1 is high, the output is high. So like this function table will demonstrate the 4 cross 1 multiplexer. Similarly, as a function table, this is also demonstrate the function of a multiplexer. See here, D0, D1, D2, D3. These are the signals available at D0, D1, D2, D3. These are the S0, S1. For S0, S1, both are 0, 0 means it will select the information at D0. So the output is D0. What are the information present at the D0 that will reflect at the Y. So D0 is having a low level, so the Y equal to low. Here it is 0, 1. 0, 1 means it will select the D1. What is the information available at the D1 that will reflect at the output? So D1 is at a high level for this case at this clock cycle, so that the output at Y equal to D1. Next step. 1, 0. So 1, 0 means it will select in a D2. So what is an information at D2 is low. So low. 1, 1. It will select the D3. Here the D3 is a low signal. So low. Again D2. 0, 0 means it will select a D0. So here D0 is a high signal. 1, 0 it will select a, 0, 1 it will select a D1. Here it is a low signal. 0, 1 it will select 1, 0 it will select an as D2, here also low signal. 1, 1 it will select as an D3, here is a high signal. So like this, if it is a 0, 0 it will select a D0, it is a 0, 1 it will select a D1, it will be 1, 0, it will select a D2, it will a D3, it will select a 1, 1. So like this, it is selecting a inputs based on the selection lines. The logic function generation using a multiplexer. So let us see one example. Implement a logic function specified in the table given below. So here the function is having a 3 inputs, A2, A1, A3. Sorry, the output is Y. This is a output of this function. So the selection lines are A2, A1, A0. A2, A1, A0. If it is a 0, 0, 0, it will select a 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, 0, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 0 here. So how can we realize a logic function by using a multiplexer? So multiplexer input variables are, it means that selection lines are A0, A1, A2, 0, 1, 2. Okay, the input data pins are 0, D0, D1, D2, D3, D4, D5, D6, D7. So what is an output? So here they gave an output 0 for 0, 1 for 1, 0, 2, 3, 1, 4, 0, 5, 1, 6, 1, 7, 1. So we'll get now 1 for 1, 3, 5, 6. So we applied a high input for 1, 3, 5, 6. The remaining outputs are remaining cases zeros. Why we are applying a 1 for 1, 3, 5, 6, 7 means see here. The output of y equal to 1 for a selection line 0, 0, 1. So 0, 0, 1 means it will select the D1 bit. 0, 1, 0 means it will select the D2 bit. So the D2 bit equal to 0. Here D1 bit equal to 1. So similarly, for a high input, I am applying a 1 here, 3 here, 5 here, 6 here. So remaining are zeros. The output function is A2 bar, A1 bar, A0. For this 1, A2 bar, A1, 0, 0, 1, 1, 3, 5, 6. So like this, we can realize a Boolean function by using a multiplexer. So this is also another example. This is a Boolean function f equal to x bar y bar z plus y x bar y z bar x y z bar plus x y z. So here, see here, for 0, 0, 0, here it is having a 1, 1, 0, 0, 0. By observing this truth table, we can realize in a multiplexer. See here. Here I am considering x, y as a selection lines. X, Y as a selection lines. So 2 selection lines means 4 inputs. So it is a 4 cross 1 multiplexer. We require a 4 cross 1 multiplexer. So for 0, 0, 0, 0, z equal to 0, z equal to 1. The f function is also 0, 1. So for these two combinations and for these two cases, 0, 0, 0, 0 case, f equal to z. Same z will be reflected on f. So f equal to z. For x, y both are zeros, f equal to 0. So if it is 0, 0, what it will select? It will select the D0 bit. So that D0 bit equal to z. 0, 1. 0, 1. What is the z? 0. F equal to 1. 0, 1. What is the z? F equal to 0. It means that for 0, 1 case, whatever the value present at the z, that will be complemented at the output side. So 0, 1 case means the multiplexer will select a 1 so that for 1, the z will be complemented. Okay, for 1 case, it will, for 0, 1 case, the multiplexers will select a 1 first D1 bit. So whatever the output of the function is, whatever the value at the z, that will be complemented so that z bar will be routed to f for 1 case. Next, 1, 0. For 1, 0 case, z0, 1, but f equal to 0. For 2, 1, 0 cases, the f equal to 0, 0. So 1, 0, 1, 0 case, what is a function value? 0. 1, 0, 1, 0, 1, 0 means state 2, D2. So D2 bit equal to 0. 1, 1. So 1, 1 case, what is an output of f? 1, 1, 1. Irrespective of z, it is having a value of 1. So 1, 1 case, if the selection lines are 1, 1, the multiplexer will select a D3. So the output equal to 1 means already we are having available information is 1. That only will route it to the output. So that the output value is equal to 1 means so the input is also 1. So for 3, 1, 2, 0, 1 equal to opposite of complement of z means z bar 0, z. So like this we can construct in a multiplexer a logic function by using a multiplexer. Thank you.